right, good morning. So we've had a couple of questions about systems of equations and how to solve them quickly and easily. And I'm sorry to tell you that there is no such thing. But let me go ahead and give you the best one I possibly can, and we'll see if we can do that. I'm actually a little bit upset about the fact that we don't actually teach this section anymore, because I think it was really useful to be able to do this. Okay. So it's in the next section. It's called matrices. Okay, there's a whole class about how to do matrices. This is a very small part of it. Okay, but this is where we're going to go. Okay. All right. So I grabbed a random 3 equations, 3 unknowns sort of a problem here. So I'm just going to write this down. This was x minus y minus 2z. I tried to find one that wasn't trivial, and I tried to find one that wasn't like everything in it is a fraction. Okay, so I'm trying to find a good middle ground of problems that you're likely to encounter. Okay, and what do we have? We have negative 4x plus y minus z is equal to 12. All right. So the first thing I'm going to do is, like, if I have to keep writing down like all of this stuff, right, it's going to get a little time consuming. And the problem is like, and I know the problem is that you lose terms, you lose signs. There's a lot of writing. It takes it's a long problem for you to maintain concentration on. That's really where the problem comes in. I know everybody's capable of doing all of the arithmetic. It's just the 33rd time you have to add like 27 and 9, and maybe one of them's a negative, you're going to start dropping stuff, and that's the problem. So the original way I was going to show you this didn't fix that problem. It was also very long. So I decided, well, okay, I'm just going to go ahead and show you the next section. So we're going to use what's called a matrix. And if you remember synthetic division, where everybody's favorite synthetic division, where we stopped writing the x's, we just wrote the coefficients. That's the same kind of an idea here. So all we're going to do is we're just going to make a little box, and I'm just going to go ahead and write in my coefficients here. So I've got 1, -1, -2, and they typically put this little dotted line here. This is your equal sign here. And on the other side, we'll have a -6. Okay. If you ever take a class called linear algebra, they will call this an augmented matrix. It's augmented because we have the little dotted line here. I teach linear algebra, and I've never asked somebody, like, tell me the difference between a matrix and an augmented matrix. So the vocabulary is nice, but not huge. There's no z. Put a 0 in. Okay, just like the synthetic division, right? If there wasn't a term there, we put a 0 in, and it's -25. Okay, and then we have -4, 1, -1, 12. Okay, so I'm going to do this kind of like a slow way because my arithmetic sucks, and I want to make sure I'm going to get all of this right. So I know there are faster ways to do this. So when I post this on YouTube, please don't tell me like you should just do it this way. I'm like, I know. I'm also doing this the way that like, I'm not trying to take advantage of any kind of special form that something might have before we get started with it. Okay, so I might be looking at this and saying, if you're experienced with this, you'll say, hey, equation 1 and equation 3, we can knock this out and then we'll have an easier time. Like, not doing it. Okay, not doing it. We're going to take it slow. We're going to take it this way, because quite honestly, like, one problem is the arithmetic. The other problem is, and I'm guilty of this, there's people who don't have a good algorithm. They'll go around in circles, and that's a major problem. So it's bad enough that you get the wrong answer. It's worse that you spent 3 hours trying to untangle a knot. So the goal is I'm going to get rid of those 2 entries. Okay, I'm going to 0 those entries out. I'm not just going to write 0. I'm going to use my, process of elimination to get rid of these, okay? And then the next one, okay, let's use a different color for step 2, phase 2, whatever. The next one, right, and I'll come back to this, is we're going to knock this one out, and then so forth, all the way down, okay? So how are we going to get rid of that? Well, what I'm going to do is I'm going to call this row 1, I'm going to call this one row 2, I'm going to call this one row 3. Okay, column 1, column 2, column 3, if you ever get that far. But what I'm going to do is I'm going to take -3 times row 1. Okay, so and this is hard. Make sure you get the right-hand side. -3 times everybody here. Okay, so that's going to be -3, right? 3, 6, and -3 times -6 is 18. Okay, my row 2 is going to be 3, 2, 0, -25. Don't forget your sign. I know that's the hardest part. And then we're just going to add these together. So it's row 2, so -3 plus row 2, and then this gets zeroed out. We get a 5 here, we get a 6 here, and then -25 for 18 is going to be -7. Okay. Yeah, I did work this out before I did it. Otherwise, I'd make a mistake somewhere along the line, and then it would be more frustrating for everybody. Okay, same process to get rid of this -4, but I don't have to do a negative here. I could just say row 4. Okay, so we can say 4, row 1, and then we're going to have row 3 underneath. Okay, let me get rid of that plus for right now. Here we go. Okay, so for row 1 is going to be 4, -4, -8, and then 4 times 6 is going to be -24. Okay, let's go ahead and separate these. All right, and then row 3, we're just going to write this down: -4, 1, -1, 12. And we're going to add them together. Okay, so this is going to be 4 row 1 plus row 2, or row 3 rather. That's going to be 0, -3, -9, right? -9. We're just adding. By the way, and that's why I multiply by the -3, because if you ask me to subtract, like all of a sudden everything is going to go south. Okay, so I do my best to minimize like having to keep track of signs, and I just add. Okay, I am a terrible person when it comes to like I've got to subtract, because I'm back in 3rd grade and now everything is going to go wonky. Okay, this is my new row 2. Okay, I'm not touching row 1. I have the same row 1 that I started with. Okay, now this is going to be my new. This is going to be my new row 3, and you might say, "Hey, wait a minute. These are all divisible by -3. So my new and improved row 3." You don't have to do this step, but I like smaller numbers, so I'm going to divide by -3. So we get 0, 1, 3, and 4. Okay, just so I can kind of keep track of everything and make it a little bit easier. Okay, so I'm just going to recap and take a look at what we have at this point, so we can continue with our plan. All right, didn't touch row 1. I know it looks like, hey, didn't you multiply it by it? I'm like, yeah, but that was just temporary. Okay, we're going to multiply row 1 by 4 and then put it back. We're going to multiply row 1 by -3 and then put it back. So I am keeping the same row 1 that I had at the beginning. Okay, -2 and -6. And now my new row 2, right, is 0, 5, 6, -7. 0, 5, 6, -7. My new and improved row 3 is 0, 1, 3, 4. And exactly what the plan was we knocked these guys out. Okay, so the next thing we're going to deal with, right, is we're just going to go down the list. We're going to go down the columns. Okay, if I had a 4 system of equation, then I would knock out this one. I would make these guys zeros, and then I would make the next one, and then the next one, and then the next one. Okay, that's just how you do it. So I don't have to worry about row 1 anymore, because I'm just trying to use row 2 and row 3 to knock this thing out. Okay, so let's see, what did I do for that one? We said, I think I have to multiply row 3 by negative 5. Okay, I think that's what we're going to do here. So we're going to take, oh, let's go back to blue. Okay, so here's my row 2. This was 5, 6, negative 7. And then we have negative 5 times row 3. And again, you have to be really careful. And I'm sorry, this is just the way that it is. Okay, so we have negative 5. We have negative 15, right? And negative 5 times that is going to be negative 20. And then we're going to add them. Okay, so you could have said, well, can't you just subtract? Like, yeah, you can. But then I have to remember how to subtract, and I don't trust myself. I like adding. Pluses are easy, even though almost the same thing. So this is 0, right? We end up with a negative 9 here, right? 6 minus 15. And then this one's pretty easy. It's negative 27. Okay. So first one was kind of bad because we had to deal with 2 rows. Second one, we only have 1 row left to knock out. So let's just recap. Actually, can I go ahead and divide this new row? So this is my new row 3. And then I'm going to divide everybody by negative 9, and I'll get my new and improved. Okay, now with flavor, row 3. Okay, so if I divide by negative 9, we get 0, 1, 3. Okay, so let's go ahead and write down our matrix. Again, this is just the coefficients. Okay, I don't. They make it harder. They make it sound a lot harder than it really is. Okay. Okay, and we have 0, 5, 6, negative 7, and then we have 0, right? 0, because actually we didn't worry about the x part, where we just had the y part, and then because this one we didn't have this 0, we didn't care about it. Okay, but we put it back in. We have to have it if you remember where it is. But this was 1, 3. Okay. Now I can't spell echelon, so I have to write that down too. Did I? I didn't. Maybe I can't spell echelon. Okay, this is called echelon form. It's when the main diagonal here, okay, let's make it look like that. When the main diagonal here has something in it, but all the entries before it are zeros. Okay. Technically, I guess this could be a 0 here, but then there's problems. Okay, not that there's problems. It's just that you're going to end up with like a no solution or an infinite number of solutions. But you know, pretty much your main diagonal entry has something in it, and then the things before it are all zeros. This is echelon form. This is all the stuff for matrices. Oh, it all seems to come from like, I don't know, like 19th century French Army or Navy formation stuff. So if you have like, you know, this comes from, if you have a boat, and then there's another boat. Okay, and this was called an echelon form, so that when they would sail, they would take this thing for whatever reason. Okay, so that's really what you want, is like a diagonal. Okay, that's echelon. You can have 2 diagonals. So when you see ducks flying, they're usually, or geese flying, they're usually in echelon form. Okay, but 19th century, 18th century French Army stuff. When you get to linear algebra, they'll call these pivots. And again, it's a French Army term. When an army would, or a marching band would like go around a corner, this person would be called the pivot. Okay, so marching formation is very important. All right, at this point, now we're going to back substitute. Okay, we're going to back substitute because at this point we have 1z is equal to 3. I think we can guess that z is equal to 3 here. And now we're going to go back one step up. So we're going to say, well, this is 5y plus 6z is equal to negative 7. I'm just pulling it back here and putting the variables back in. So we're going to say, well, this is 5y plus 6 times 3 is equal to negative 7. 5y plus 18 equals negative 7. 5y equals negative 24, negative 7 minus 18. Okay, if you got to check that in the calculator, then so be it. Don't get this far to mess up the last or the penultimate step here. That's second to last. So y is my negative 5 here. And then finally, we're going to plug back into row 1. So row 1 looked like x minus y minus 2z was equal to negative 6. Okay, that way I don't have to scroll all the way back up. So x minus negative 5. Again, the parentheses are just, it's the worst. Okay, and I get that. Z was equal to 3. Excuse me, equals negative 6. So we have x plus 5, right? Minus 6 equals negative 6. So x minus 1 equals negative 6. X is equal to negative 5. Okay. So my solution, negative 5, 3. Okay. So I think I have time. I think I can do one more without making this video too terribly long, provided I wrote it down. Okay. Did I write this next one? I did write it down. Okay. So again, this one is out of your book, okay, and they do something very cruel to you when they start this one, okay. They give you a glimmer of hope, and then they yank it away, only to watch you fall on your face for it. Okay, 5x is equal to negative 3y minus 3z plus 1. We have 6y is equal to 6z minus 25x plus 9. Okay, and then 6z is equal to negative 5x minus 3y. So this is why this one is a cruel joke, is because you really want to put this thing on standard form. You want all your variables on one side and all your constants on the other side. So your first job here is to ignore the lure of trying to, like, well, maybe I could substitute. Like, well, maybe you could. I got news for you. It's not going to work out well. Okay, you're going to, I mean, it's possible you could do well with this, but chances are there's going to be like a knot you're going to end up tying, and you're going to be going back and forth a little bit. So the method I'm using tries to minimize the wasted time in trying to figure out which variable to solve for and how you do it. This just gives you a constant way to do it over and over and over again. So we have 5x plus 3y plus 3z is equal to 1. We have 25x, line them all up, okay, plus 6y plus 6z is equal to 9. And then we have 5x plus 3y plus 6z. Hey, there's nothing left, 0. Okay, so my matrix form of this thing, okay, 5, 3, 3, 25, 6, 6, 5, 3, 6, and then we augment it, put a dotted line there, 1, 9, 0. Okay, they make a big deal about doing this like in chapter 1 of your linear algebra book, and then they'll never do it again. So you can put the dotted line in. I find that it helps, but if you don't put it in there, it's not like a major, it's not a big deal. Okay, most books will stop doing that after a bit anyway. So what I'm going to do is minus 5 times row 1, and then we're going to add that to row 2. Generally, see, we're not really changing row 1. We're going to put it right back to where it was. Generally, we want to multiply by row 1, by the row that's not going to change, to add to the row that you're going to replace. So we're going to replace row 2 here. So we have negative 25, right? Negative 5 is negative 15. Negative 15. And again, if you find subtraction easier, then you go right for doing subtraction. Okay, and this is 25. This was 6, 6, and 9. Let's see. Wait a minute. My notes have something a little different here. Aha! This right here, I missed a sign. See, I'm kind of glad that I worked this out a little bit. Although now, right, now it's not genuine because I say, well, you missed a sign. I'm like, yeah, I did. So I'm not going to lie to you and tell you that, you know, there's an easy way to do this that's error proof, because there simply isn't. Well, there's one way that is less error prone than the others, and that's by punching it in a calculator. And I'll show you how to do that in a minute too. Okay. So we're going to add. All right, I'm just going to add. So there we go. This is my new row 2 here. Okay. This is 0. Negative 15 plus that is going to be negative 9. That's going to be negative 21. And then we have 4. Okay, so double checking a little bit. All right, this is my new row 2. Row 1 remains untouched. Okay, row 1 is still this guy right up here, 5331. And then what I have to do is I have to take negative row 1 plus row 3. Okay, and again, this isn't like the magic, it must be done this way. Okay, kind of a thing. Let's go ahead and do it this way. Negative row 1, and then we'll put row 3 here. Okay, you will find your own ways to do this. But now that you have more tools to say, oh, it's this is a matrix, and you can look at YouTube for like how to do row reduction with matrices. Yep, that's negative. And then we're just going to write down row 3, which is 5, 3, 6, 0. Okay. And add these together. Let's see, this one, I picked this one because the beginning problem made it look like it was going to be a pain. But it turned out that it really was a nice, easy problem to deal with. Because on my recap here, okay, let's go down here and do a recap. So what matrix am I looking at? We've got a 5, 3, 3, 1. We've got a 0, negative 9, negative 21, 4. Let's double check. Is that what I have up here? Negative 9, negative 21, 4. Okay. And then we have a 0, 0, 3, 1. Negative 1. Okay. Again, nothing is error proof. All right. And I'm sorry. That's the way we have it. All right. When you're taking my class, if if other people are watching this, when you're taking my class, like, I understand that arithmetic mistakes are going to be made. I'm looking more for your process of how you solve this than your accuracy in solving it. All right. I'll see part 2 here. But at this point, right, we're already in echelon form. Okay. Okay. There's like reduced echelon form and like row reduced echelon form that you can get into. I'm just trying to get the most efficient way through this, and you can crawl up and knock out. We can do the process in reverse here and knock out this one and this one, and then knock out this one. That takes a lot more operations. Okay, this one, if you ever have to study numerical analysis and say, well, how's the best way to do this? Stopping here is the best way. 3z is equal to negative 1. Z is equal to negative 1/3. Oh, delightful. They gave us fractions. All right. Next one up. Okay, that was row 3. We solved for z. Row 2, we're going to be solving for y. So negative 9y minus 21 times negative 1/3 is equal to 4. I suppose we could have multiplied through by negative 1 here. Whatever. Okay, so 21 over 3, what is that, 7? Okay, it's equal to 4. So if I go ahead and subtract 7 from both sides, we get negative 9y equals negative 3. Oh, joy, they gave us another fraction. Okay, so we have one solution, we have two solutions, and then back to the original, which was 5, 3, 3, 1. At least this one's going to be okay. So 5x plus 3y plus 3z is equal to 1. Right? And is it all pluses? It is. So we have 5x plus 3. I guess I kind of cheated on this one. I mean, it looked hard at the beginning, but boy, this fell apart real easy, didn't it? So this is 5x plus 1 minus 1 equals 1. 5x equals 1. X is equal to a fifth. Okay. So 1/5, third, negative 1/3, right? Yep. And those are my solutions to this particular system. Okay. So hopefully that speeds you up a bit and reduces the errors in transcription a little bit. You're never going to be error free, but we have that. Actually, let me show you one. Okay, I can do the last little bit here. Okay, calculator. So in your calculators, if you have a fancy one like this one, let's go ahead. Yeah, we'll keep this. We'll keep this one. Let me go back to my original problem here. I don't know who that was. Oh, there it is, I think. Yep, there we go. So my original matrix, right? Back to this one, so I don't have to scroll all the way up. This was 5, 3, 3, 1, 25, 6, negative 6, 9, 5, 3, 6, 0. Okay. So there are 1, 2, 3 rows, 1, 2, 3, 4 columns. Okay. So this is a 3 by 4 matrix. 1, 2, 3, 1, 2, 3, 4. So what we're going to do in our calculators is we're going to see there's a matrix button here. Okay, not the movie. And we're going to go through and we're going to say edit and pick any one you like. Okay, it doesn't really matter, but we'll just pick this one. And I'll say it's a, because you have to tell the calculator what it is. It's a 3 by 4. Okay, and then we're just going to type in our entries. So we have 5. I'm hitting return. Okay, so you can hit the enter button down here and it'll take you to the next entry. 5, 3, 3, 1. Okay, 25, 6, minus 6. I hope. Nope, didn't like that. Dang it. Got to be careful with these because the calculator does not like minus sign. Okay, so we had oh, okay, here we go. We have negative 6. All right, 2 by 3. So we had 25, 6, negative 6. Oops, come on. Enter, fine. And then 9. Okay. So be careful with the negative signs. These are very, very picky about how they want things done. And then 0. All right. Now, I'm not a good calculator user, so I'm kind of stuck at this point. Okay, so I'm going to quit the matrix mode, go back into matrix mode, and we want to go to math. Okay. And now there's a whole bunch of things you could do here. You want to go down to RREF. See, REF is reduced echelon form. You still have to back substitute from here. Reduced row echelon form, RREF, okay, that will give you just entries on the diagonal, and it went through and did all the arithmetic to get rid of all this other stuff so you don't have to back substitute. So we're going to hit enter on that one. We're going to go back to matrix. I hope we're going to hit A, enter, enter, boom. Now you have your matrix sitting here. And you're like, wait a minute, my teacher said I have to make it a fraction. Glad you asked. Math, turn it into fraction, boom. And now we have x is equal to a fifth. Second function, y is equal to a third. Third one, y is equal to negative 1/3. If you're in my class and you have this on your exam, yes, you must do this and show me you can do it by hand, because somewhere in the world you're going to be doing this. t. And now you're kind of stuck because what are you going to do? Okay. However, nothing says that you can't peek at your answer. All right, you can't peek in the problem here and figure out what the answer is supposed to be, so that you know whether or not you got it right or wrong. Okay, so it's a little part of the learning process. Even though like I'm being tested on it, like you're still learning it. Okay, you're never going to be completely error-free out of this thing. It takes me about 3 weeks into teaching linear algebra before I start making stupid mistakes. But you know, I still do. Everybody who's happy for linear algebra is like, yeah, that guy can't add. So that's how you do with the calculator. Okay, practice with the calculator a little bit. There's plenty of other better videos to show you how to do this with a TI, and practice doing it this way. And hopefully that will cut down the amount of time that these problems take, which will in turn cut down the errors. And if you use this algorithm of knocking out the first variable, then the second variable, and then the third one, and so forth, hopefully that'll eliminate the errors of like going back and forth, and I hope that helps. Okay, so thank you for that, and I will post this and let it go. Thank you.